So this is a strong version of the proof I showed in the previous video. And the reason I feel I need to do two is that the more complete version of the proof depends on something we haven't learned yet. But we are going to learn about the side angle side postulate and some of the other triangle postulates soon, so I may as well introduce this one now. So again, we're going to drop an angle bisector down right here, but this time we'll label this point M because it's a point in between A and C somewhere. In fact, let's label it D, because we don't know for sure that this is the midpoint. We don't know for sure that that's a 90-degree angle. So we can't have a proof that depends on that. But what we can know for sure is because this is an isosceles triangle, this side here is congruent to this side here. And because this is an angle bisector, this angle here is congruent to this angle here. So what we're going to do is compare triangle ADB to triangle CDB. And we know that AD, and we also know when talking about congruence, this line segment here, BD, is congruent to itself through the reflexive property. So what we have is a shared or congruent side, a shared included angle that is congruent, and then another pair of congruent sides. So because we have side, angle, and side that have been shown to be congruent, that means that we have two congruent triangles. And one of the things that we know about congruent triangles is that their corresponding parts are congruent. So if triangle ADB is congruent to triangle CDB, that means all their parts are congruent. This little segment here is congruent to this segment here. So AD is congruent to DC. And then this angle here will be congruent to this angle here because those are corresponding parts of two congruent triangles. So angle A is congruent to angle C, which is exactly what we were trying to show in the beginning.